Alright, let's get started. Cantilevers and further support. Okay, you got that? Yeah, let's have a look. Cantilevers will be looked. What was I don't think that's quite. I at least should have said cantilevers will be looked at. Okay. Right. So these are what's called cantilevers. This is a simple cantilever. This one is called a braced cantilever, and this one is called a braced cantilever as well. But the difference between the two is for this cantilever, the support is under via a compressive strut. Whereas here, in this cantilever, the support is with a string called a tensile stay. Wait. Before you continue, in a moment I want you to draw this with the words. But before you do that, let's think of some examples where we might see this. So where would we see a simple cantilever?
Small bridge. What?
Yes, maybe so. Maybe so. Very small bridge. Where maybe something from home though. Where might you see it in a house? Balcony. Yeah, balcony would be a simple cantilever. Yeah, good. Okay. What about the next one? A braced cantilever with a compressive strut. Which one? Huh? Showers? Shelves. Oh yeah, but it would have to be a very big shelf if it needs this. Yeah, small shelves no, but a big shelf yes, you would have something like this. But I don't really know. I don't really think. Yeah, I think you'd be more likely to see something like this. Well, maybe not in your homes, but in my house, at the front door, there's a little porch. And the porch has a piece of wood at an angle here supporting it, you know, so the porch. And I don't know about the last one, a braced cantilever.
Also shelving the back.
I was just thinking a shelf that you might pull down from something.
Or in the boot of a car and then hangs it.
Ah, yeah, that's good. Yeah, that would be an example. Yeah. So these are all cantilevers. There is one cantilever outside Sylvia's office. I'll let you see if you can find it later. Okay. You can see which one it is. When you're outside Sylvia's office, there's a cantilever somewhere.
Whose office is
The admin office.
Oh.
Yeah. Now, draw this and then we'll look at the definition. Yes. So you saw on the news that Syria waited no time in sending troops into. Sorry, Turkey waited no time sending troops into Syria. And they only waited 3 days before sending troops in.
They were already done. Like,
I'd
they were
say,
really waiting on that.
I'd say so, yes. Just waiting for the chance. Okay, you got that drawn? Yep. The definition is quite difficult. Like, how do you describe this in English? Okay, so we'll do it slowly. A cantilever. Okay. Now, wait. Before you write this down, I want to make sure you understand each word. So, a cantilever is a rigid. What's the meaning of rigid? Solid, yeah. Structural element.
Structural element, something that holds weight.
Yeah, like something on a building site. Like structural element means like a piece of construction, a piece of a building. You know,
And that is holding weight.
it's usually holding weight. Yeah.
You also have.
Yeah. So like in this room, I suppose the wall would be a structural element because it's holding up the ceiling. Yeah, this wall seems structural element. What else? Oh, look, that's kind of like the brace.
Yeah.
You know.
Yeah.
Okay, so that's fine. Right, next. Such as a beam or a plate. So this shape would be called a plate, whereas something like this here, I guess you could call something like this. This is like a beam, you know. Next. Anchored at one end. So anchored, free. Free, kind of. Anchored. What does anchored mean?
Fixed.
Fixed.
Yeah, but it's kind of,
Well,
this is also fixed, kind of, so, and this is also kind of fixed. Like, what does anchored mean here? It does mean fixed, but a very particular type of fixed.
Attached at the bottom.
Structurally attached at the base. So, yeah, like anchored means, in English, when you say anchored, you usually mean only to a wall, attached to a wall. Okay, so I would not say this is not anchored. Okay, because anchored means like it's attached to the wall and it's really, really attached, like it's really strong. Here, I could say this is anchored. Okay, because I could probably put a lot of weight here. It shouldn't move. Okay, but I can't say this is anchored because it's not on the wall, and I could kind of move it a little bit. Do you know what I mean? Yeah. Do you understand the meaning of anchored? Yeah. When you're making a shelf, you know, put a shelf on the wall, you need to make sure it's anchored here so that when you put a weight on it, it doesn't fall. So anchored means really secure. Usually to the vertical, from which it protrudes. So what does protrude mean? Goes out, yeah. So it's anchored to the vertical and protrudes out. Protrude means sticking out. Now, look, don't worry. They won't ask you this in the exam. But there's lots of good English in here. So, you can write that down. Learn lots of new words today. Yeah? You got this written down? So a few months ago, I had to put up in the bathroom a metal shower curtain that goes around the bath. Do you know what I mean? Like an oval shape goes around the bath. And you can't just screw it into this wall. Why not? Do you know?
Is that so structural?
It's not structural. Yeah. Like if you screw something into this and you pull on it, it'll just You know, it's not structural. So what you have to do is go into the attic, and you have to anchor it to a piece of wood on the other side, like on the roof. Because this is not structural. You have to anchor it to a beam on the other side. You know? So I think if I wanted to, I could probably hang out of the curtain. It shouldn't fall down from the ceiling, because I have it attached to a beam on the other side of the attic. But I'm not going to try it, but I'm sure I could. All right, you got that? Yeah. Now, I have two examples to do. They're kind of big examples. I might change this a little bit. I think I will change this a little bit, but I'll keep this one the same. So I'll do that one in a moment, but I'll just make up my own one here first. Okay, so what type did I have? I had a stay. Okay. So this will be an exam type of question. You'd have a wall here, and you have a cantilever, and then we'll put a weight. We'll put a weight right at the end, okay? And we'll say that this one is 2 kilograms, and we'll say the cantilever will make this one 10 kilograms, okay? And we'll keep everything nice and simple. We'll make it 50 centimeters, and then we'll have our rope here right at the end as well. We'll make that 40 centimeters so that this piece here could easily be 30 centimeters. Okay, we'll keep everything nice and straightforward. All right. So my first question, I've changed the story a little bit, I think. Yeah. First question is, what is the tension here in the stay? So let's draw all the forces. There's a T here. There's a force here. How much? Yeah, so in this case, 2G. Yeah? There's a force here in the middle. How much is that? 10G. And on this cantilever, there's one more force here. What direction is it? So I'll give you many choices. You can have 1, 2, 3, 4, 5, 6, 7, 8. Make your selection. What do you think it is? So 1, 2, 3, 4, 5, 6, 7, 8. What do you think?
6.
You're going with 6, okay? Anyone differ or agree? 6 or 8 are quite different. You're going with 7, okay? So I have 6, 7, 8. Great.
What was down? Actually?
Yeah.
6, man.
You're going with 6.
Yeah.
Anyone else? Now there's 3 choices so far selected, 6, 7 or 8. The only thing they seem to have in common is to the left. Any other choices? No?
No, I would say 8.
You're going with 8, okay.
Yeah.
What do you think? Are you just saying that because he said it?
No, I don't think it's.
You don't think it's 8, but you're going with 8.
What is it?
What do you think? Yeah? Thinking 6 or 7? What are you thinking?
Yes. 8, 6, 1 over.
One of them, what do you think? Okay. You're all wrong. It is this one here. Okay, now let me explain. Right? The reason is there are 2 forces here which combine to make that. Now why are there those 2 forces? So if you think about it, I'll show you. Imagine this is the cantilever. Okay. It's against the wall. Why does it not move into the wall? The reaction of the wall. So there's a force out from the wall. There's a force into my arm. Okay? Why doesn't it fall down? Yeah, because there must be something here holding it up, like a nail or a screw or something like this. So there are two forces here. This one stops the cantilever going into the wall, right? And this one actually is supporting the cantilever, like if it's a screw or glue or something like this, you know? It's giving it some up support. So together they make the reaction this way. Yeah? Are you happy with that? You look shocked. You look shocked like you just saw something horrible. Is this okay or not okay? It's okay, are you sure? Yeah?
Actually, I was thinking it should be 2, but...
You should have gone with your instinct. You were listening to all of them. Trust yourself. Okay, so let's continue now. So what I'll do is, I'll call this or, and just to make it easy, I'll call this part or x, or just x maybe, and this one here y then. Okay? Right. So, let's see what formulas we can make. We can say y, oh, and also this has a theta here, doesn't it? So this is t cos, and this one here is t sine. Now, and that's theta. Can anyone tell me what cos theta and sine theta are? So if you look at the triangle, what's cos theta? Cos theta is... Oh, guys, what have I done so stupid? Somebody.
You've switched the...
Yeah, 40 and 50 are the wrong way around. Nobody told me. 40 and 50. Thank you, so stupid. Right, what's cos theta? 40 over 50. And what's sine theta? 3 over 5. Okay, so if this one is t cos, then that would be 4 over 5t. And this one here? 3 over 5t. Okay, so you can say y plus 3 over 5t, what should that equal?
12g.
Very good, 12g. Because what are we saying here? Upward force equals downward force. Yeah? X equals what? Yeah, come on. Don't be shy. Vertical? No.
I mean horizontal.
Yeah, so? Yeah. Come on. 4 for 5t. Yeah? Yeah? Are you okay? What's wrong, guys? Did Colin wear you out? No? Is this okay? What is making this equation? What am I saying here? Left equals the right, yeah? Yeah, it's balanced, yeah? Alright, let's continue. Now, the last one I'll do is turning force, the moments. Okay? What would be a nice turning point to use?
The weight of... Oh, no, the actual force.
Which part? Oh, at the end here?
Yeah.
Nah.
That should be the...
I think this would be a great one, because you can get rid of x and y. So, clockwise or anti-clockwise here? Clockwise. And this one going up? Anti. And this one going down? Clockwise. And this one going left?
It's through the points.
Yeah, so no effect. No effect. Okay, so now we can say 0.2 times 10g, yes, plus 0.4 times 2g, that should equal 0.4 times 3 over 5t. This one here. Yeah. I'm saying the clockwise equals the anti. And here I'm saying the left equals the right. And here I'm saying the up equals the down. Equation 1, equation 2, equation 3. Which is the best equation? Which is best? Which is most helpful? Which one? 3. What can I get from 3? What does this give me?
T.
Gives me t. And then what do I do? I put in here, don't I? And then that gives me x. And then what do I do? I can also put it in here as well.
Yeah.
And this gives
Y.
me y. Now, if I know x and I know y, how can I get or?
Result.
Yeah, what formula gives me the or?
A squared plus B squared.
Yeah, that's called
Pythagoras.
Pythagoras. So I can put it into here, and this gives me or. So I can know t, x, y, or. I can get all the forces, which I think is probably what I asked. Oh yeah, and then the last thing I also asked for is what's the angle here? Let me call it alpha. Alpha. How do I get the alpha here? What do I type? What do I use? I use tan inverse. Come on, how do I get the alpha here? Tan inverse
Y over R.
y over
X.
x. You remember we did this in vectors? Remember? Yeah? Good, because I'm going to ask you to calculate these. I want t, x, y, or alpha. See if you can do this.
It's just algebra. Right?
Yeah. Well, copy this down too. Anybody get the T yet?
T.
Yeah.
114.45.
Anyone else get it yet? 2? Okay. Finished? What did you get for tea? Let's see if you match. Diego, what did you get for tea? Tea. Yeah. Yeah. That's what you got, isn't it? Yeah, 45. Okay, what did you get for X then? Should be about 90.
Yeah, 91, 56.
56. Excellent, excellent. And what did you get for Y?
Minus 73.
Minus? Oh, I don't know. 49.05. Yeah, it's not minus. You made a boo-boo.
Maybe.
Yeah, you did. These seals aren't good at calculators. Right. What's the OR then? About 100, is it? Or what's the OR? Did you get the OR? What'd you get? Yeah. 103, okay. And then lastly, the angle of the reaction. What'd you get? 20 degrees? 20 something? 28.2, is it? Okay. What did you do wrong?
Didn't put G.
Ah, yeah, 12 minus 3 over 5t, huh? Yeah? Okay, we got that? Yeah. So there's one more example to do, but we don't have time to do it because it takes time as well. Do we have class tomorrow? We do? 1 hour?
No, tomorrow.
No, I don't think so.
So can you just zoom on the picture?
You want me to zoom in on the picture?
Yes, please.
So listen, no homework from this lesson. We'll finish it on Monday. But what I want you to do is make sure you have all the questions finished in the change of momentum and the turn in force and everything we did this week. Have all the questions finished. Yeah? Okay. We'll finish there.
Can you zoom out?
Zoom out now.
Yes.
Alright. This?
Yeah, perfect. Thank you.
You got class in here next or are you free?
No,
Free.
Maths and D2 and 3.
Alright.
Only one question is for this class.
Yeah, but they take a little bit of time to do. Okay. See ya. See ya. You too.